All right, today we're talking about distributive property, which you guys saw last year, correct? We kind of touched on this a little bit yesterday. We went over just a couple examples, okay? So here we're going to talk about simplifying. Actually, yeah. So before we get into actually using distributive properties, I want to just remind you of something. Yeah. Like terms. When I say like terms, can someone tell me what that means?
3A and 4A.
Hey. Okay, yes.
Whole numbers or variables. I thought it was just the same thing. Yeah.
True. Yes. Okay. That's yes. Or it could just be numbers that don't have variables, right? Are also like terms. Okay. So just as a reminder, like terms are the same variables with the same exponents. Okay, because we're going to start getting into some things that have different exponents. But if they, like 6a and then 4v or 4a squared are not like terms, right? Let me write this down.
Do we need to write this?
You can. You don't have to. Okay, why are these two things not like terms?
One has exponent, one doesn't.
Yeah, they have different exponents. So you can have things that have the same variable, and a lot of times, like I see kids going through this, and they'll say, well, they have the same variable, so they're like terms. But if they don't have the same exponent, then you cannot add them together. Okay? So the first thing we're going to look at today is just simplifying or combining like terms. Okay? Anybody still writing that? All right. We'll start with just some simple ones, and then we'll move through. Okay, so if I have 17u plus 25u, are these two things like terms?
Yes.
Yes, so I can add them together, and I get a total of what? Yep, somebody up there said it. 42u, right? So we add the numbers, we keep the variables. All right, our second example we're looking at is 6t squared plus 3t minus t. So somebody raise your hand and tell me, okay, Callan, what are my like terms here?
3T and T.
Okay, 3t and t. So do I do anything with this 6t squared?
No.
Just bring it down for my answer.
It has an exponent.
Okay, and then Callan, what is 3t minus t?
2T.
Good.
2T.
Okay, so we get 6t squared plus 2t. All right, JC, did you want this one?
Oh, sure.
Okay. Identify me first. What are my like terms?
2y and 8y.
Okay. So if I'm not using 4y cubed, I just bring that down. What is 2y minus 8y?
Negative 6y.
Good. And then what do I do with the plus 5?
Leave it.
Just bring that down. Okay. All right. I think we're okay with those things. Yes. Let me show you one with a fraction real quick. Okay. Now, are these two things like terms?
Yes.
Yes, because they both have x, but can I subtract them the way they're written right now?
No.
No.
Why?
The letter, because you cannot subtract the lower fraction.
Because the fractions don't have what?
A common denominator.
Common denominator, okay? Can I make one of them have a common denominator with the other?
Yes.
Yes.
You multiply 1 and 2 times 2.
Good. Okay, so we could change that to 2/4 x minus 3/4, right? Well, now I can subtract. What is 2/4 minus 3/4?
-1.
-1/4, right? We subtract the top number, keep the bottom number the same. Good. Okay? All right. Now that we're okay with that, we're going to look at some distributive property. Okay? Anyone still writing any of this down? Okay.
Now what are we doing?
We're going to look specifically at like using distributive property. Now, here's the deal. We talked about the other day what operation is shown with the 7 and everything inside parentheses.
Multiplication.
Multiplication, right? So I know I'm going to take 7 times 3w, and I'm going to take 7 times -5, okay? Now, here's the deal. You guys are going to hear me say a lot. I will call this whatever number it is with the sign in front. And I always have people say, well, isn't that a subtraction sign? It is, right? But we know in math, you can always change subtraction to addition and change that sign to the opposite, correct?
Whoa. I never knew that.
Yes, every time. Instead of subtracting, you can add the opposite. So really, it's plus -5. Well, instead of doing that every time, I'm just going to call this -5, okay? It usually will help you, I think, as you go through that, okay? Here's the other thing I'm going to show you on the first one. I'm not going to make you do it every time, but what this means is 7 times 3w minus 7 times 5, correct? Now, I'm not going to make you write this step every time. I'm going to show you on the first one. After that, we'll just do that step as we multiply through, okay? So, what is 7 times 3w?
21W.
21w minus what?
Plus
Minus
negative.
25.
Well, here you could just bring that down, or like you can look at this two ways. You could bring down the subtraction sign, and then it's 7 times 5. Or you could say it's -7 times 5. Well, what's -7 times 5? -35, so we would write -35, okay? More often than not, like when we don't rewrite it this way, I'll just say 7 times -5, -35, okay? Cayenne, can I add these two things together? No. Why?
Because they don't have any like,
Good. They don't have any like terms. Now, does this example still show distributive property? Yes, right? I have something in parentheses, 3 terms, called a trinomial, and then I have a single term on the outside called a monomial, 1, that I'm going to distribute to everything on the inside. So it's the same idea, we're just going the opposite way. So I'm going to do 4 times 6v squared, 4 times v, 4 times -3. Okay? Who can tell me what 4 times 6v squared will give me? Good. 24v squared. We multiply the number part, we keep the variable. What about 4 times +v?
4B.
So positive 4v or negative?
Positive.
Positive, so we're going to write plus 4v. And then what about 4 times -3?
-12.
So we put -12 or -12 right there. Okay? Can I combine any of these terms together?
No.
No, right? Because I have a v squared, a v, and then nothing. So I don't have any like terms here. Okay? We feel okay with that? Okay, one more example on this, and then I'm going to show you our last type of problem that you're going to see. Okay? Let's do here. Now, here's something I want you guys to start seeing, is when we see a fraction, we don't always have to reach for our calculator, okay? Because it is possible to do this without a calculator, and I'm going to show you how. What am I doing with this 20?
Multiply.
Multiplying it by what, Callan?
2 over 5.
and -2. Okay? Now, here's the deal. Most of you are going to see 20 times 2 over 5 and think, I don't know what that answer is. Let me show you how to do that. Okay? If it was just 20 times 2, would you know the answer? Yes. What is 20 times 2? 40. So this is now 40 over 5. What operation does that show? Division. What's 40 divided by 5? Hey, somebody might check their phone and make sure it's turned off. Have you guys been shown that before with a fraction and a whole number?
No.
If you have a whole number times a fraction, you can multiply the whole number times the top and then divide by the bottom. The other thing you could do is you could start with division, right? What's 20 divided by 5? 4. Well, what's 4 times 2? Also 8. So either way works, okay? You can multiply the top number, divide the bottom. It's an easy way for us to kind of work with fractions. Agree? Okay? All right. Then all I have to do is 20 times -2. -40. Okay? No like terms there, so I'm done. All right? Do we feel like these types of problems are doable?
Yes.
Yep.
The one thing I'm going to tell you is be careful with your signs, okay? That's the biggest place I see mistakes. All right, last one, last type of problem, okay? We are going to rewrite using distributive property and then solve. Now, I'm going to kind of show you on this first one, okay? And then we'll go through it together. Now, here's the deal. If we're working with numbers like 497, do you think I'm okay with you having your calculator out? Yes, okay. I am. So if you have your calculator and want to get it out, that's fine. So, right now, does this look like a problem that's set up to use distributive property?
No.
No. So we want to recreate one. There's a few ways you can do it. Here's how I would do this one. I'm going to keep the 7 the same. And then in parentheses, I'm going to change this to some kind of addition or subtraction problem. So what number is really close to 497 that we could start with and subtract something to get to 497?
496.
True. 500 is really what I was looking for. So 500 minus what is 497? Minus 3. Okay? Now, here's where you have to be careful. This number has to be equal to whatever subtraction or addition problem you create. Does that make sense? Okay? Like I couldn't say 500 minus 2 because that would be 498, which is not the same. Okay? So it has to be the same. So 500 minus 3 gives me the same thing, but now I can distribute this a little bit easier, right? Because what's 7 times 5?
35.
So that would be 3,500 minus, what's 7 times 3? 21. Well, now, you probably could do this without a calculator. You might still need one, which is fine, but that's going to give us 3,479. The point of rewriting this is to try to help us maybe not have to use our calculator as much, but sometimes you still might. Okay? All right, let's look at another one. Let's do this. 36 times 3 1/4. Now, anytime I have a fraction, I would separate that as your addition or subtraction problem. Okay? So, I could change this to 36 times what? 3 plus 1/4. Now again, what it kind of does is help us be able to distribute better and maybe not have to use a calculator. Does anyone know what 36 times 3 is?
108.
108. Okay, now again, we just talked about this. What's 36 times 1?
36.
36, and 36 divided by 4?
9.
Okay, can I easily add 108 and 9 together? And what do we get? 117. Okay? All right, I'm going to do one more problem. And then I think we'll be okay. Let's do 5 times 89. Now, I'm going to ask, does anyone have an idea how I could set this up?
The same way you did number 1.
Okay? Tell me, Callan.
7,
Well, instead of 7,
5,
5.
parenthesis, 190.
I would use 90, yeah. Minus what?
1.
Minus 1.
1.
Good, because 90 minus 1 is still equal to 89. But now I can easily distribute and maybe not need a calculator. What's 5 times 90? 450. Minus what? 5. Well, I can do 450 minus 5. What do I get?
445.
Good. 445. Okay? All right. How do we feel about today's? Doable? Okay. Okay, we're out of the book, so